Mumps, or alternatively M, is a general-purpose computer programming language that provides ACID transaction processing. Its differentiating feature is its built-in database, enabling high-level access to disk storage using simple symbolic program variables and subscripted arrays, similar to the variables used by most languages to access main memory. The M database is a key-value database engine optimized for high-throughput transaction processing. As such, it is in the class of schema-less, schema-free, or NoSQL databases. Internally, M stores data in multidimensional hierarchical sparse arrays. Each array may have up to 32 subscripts, or dimensions. A scalar can be thought of as an array element with 0 subscripts. Nodes with varying numbers of subscripts can freely coexist in the same array. Perhaps the most unusual aspect of the M language is the notion that the database is accessed through variables, rather than queries or retrievals. This means that accessing volatile memory and non-volatile storage use the same basic syntax, enabling a function to work on either local or global variables. Practically, this provides for extremely high-performance data access. Originally designed in 1966 for the healthcare industry, M continues to be used today by many large hospitals and banks to provide high-throughput transaction data processing. History Genesis Mumps was developed by Neil Pappalardo, Robert Greens, and Kurt Marble in Dr. Octo Barnett's animal lab at the Massachusetts General Hospital in Boston during 1966 and 1967. The original Mumps system was, like Unix a few years later, built on a spare DECP DP7. Octo Barnett and Neil Pappalardo were also involved with MGH's planning for a hospital information system, obtained a backward-compatible PDP-9, and began using Mumps in the admissions cycle and laboratory test reporting. Mumps was then an interpreted language, yet even then, incorporated a hierarchical database file system to standardize interaction with the data. Some aspects of Mumps can be traced from RAND Corporation's JOS through BBN's Telcomp and StringCorp. The Mumps team deliberately chose to include portability between machines as a design goal. Another feature, not widely supported for machines of the era, in operating systems or in computer hardware, was multitasking, which was also built into the language itself. The portability was soon useful, as Mumps was shortly adapted to a DECP DP15, where it lived for some time. Mumps was developed with the support of a government research grant, and so Mumps was released to the public domain, and was soon ported to a number of other systems including the popular DECP DP8, the Data General Nova and the DECP DP11 and the Artronix PC12 minicomputer. Word about Mumps spread mostly through the medical community, and by the early 1970s was in widespread use, often being locally modified for their own needs. 1970s By the early 1970s, there were many and varied implementations of Mumps on a range of hardware platforms. The most widespread was DEC's Mumps 11 on the PDP-11, and Meditech's MIIS. In 1972, many Mumps users attended a conference which standardized the then fractured language, and created the Mumps Users Group and Mumps Development Committee to do so. These efforts proved successful. A standard was complete by 1974, and was approved, on September 15, 1977, as ANSI Standard, X11.1-1977. At about the same time DEC launched DSM-11 for the PDP-11. This quickly dominated the market, and became the reference implementation of the time. Also, InterSystems sold ISM-11 for the PDP-11. 1980s During the early 1980s several vendors brought Mumps-based platforms that met the ANSI standard to market. The most significant were, Digital Equipment Corporation with DSM. DSM-11 was superseded by VAX DSM for the VAX VMS platform, and that was ported to the Alpha in two variants, DSM for OpenVMS, and as DSM for Ultrix. InterSystems with ISM on VMS, M/11 Plus on the PDP-11 platform, MPC on MS-DOS, MDG on Data General, MVM on IBM VMCMS, and MUX on various Unixes. Other companies developed important Mumps implementations, Greystone Technology Corporation with a compiled version called GTM. Data Tree Incorporated with an Intel PC-based product called DTM. Micronetics Design Corporation with a product line called MSM for Unix and Intel PC platforms. Computer Consultants, a Houston-based company, originally created CCSM on 6800, then 6809, and eventually a port to the 68000, which later became Mumps, a Mac OS-based product. They also worked on the MGM Mumps implementation. Global also ported their implementation to the DOS platform. Global Mumps was the first commercial Mumps for the IBM PC and the only Mac implementation. Tandem Computers developed an implementation for their fault-tolerant computers. This period also saw considerable MDC activity. The second revision of the ANSI standard for Mumps was approved on November 15, 1984. 1990s. On November 11, 1990, the third revision of the ANSI standard was approved. In 1992, the same standard was also adopted as ISO standard 11756-1992. Use of M as an alternative name for the language was approved around the same time. On December 8, 1995, the fourth revision of the standard was approved by ANSI, and by ISO in 1999 as ISO 11756-1999. The MDC finalized a further revision to the standard in 1998, but this has not been presented to ANSI for approval. InterSystems OpenM for Windows NT was released, as well as OpenM for Alpha OSF and Alpha VMS. In 1997, Unicode support was added in InterSystems Euro unregistered trademark catcher copyright 3.0. 2000s. By 2000, the middleware vendor InterSystems had become the dominant player in the Mumps market with the purchase of several other vendors. Initially they acquired Data Tree Incorporated in the early 1990s. And, on December 30, 1995, InterSystems acquired the DSM product line from DEC. InterSystems consolidated these products into a single product line, branding them, on several hardware platforms, as OpenM. In 1997, InterSystems launched a new product named Catcher Copyright. This was based on their ISM product, but with influences from the other implementations. Micronetics Design Corporation assets were also acquired by InterSystems on June 21, 1998. InterSystems remains the dominant Mumps vendor, selling Catcher Copyright to Mumps developers who write applications for a variety of operating systems. Greystone Technology Corporation's GTM implementation was sold to Sanchez Computer Associates in the mid-1990s. On November 7, 2000, Sanchez made GTM for Linux available under the GPL license, and on October 28, 2005, GTM for OpenVMS and True64 Unix were also made available under the AGPL license. GTM continues to be available on other Unix platforms under a traditional license. During 2000, Ray Newman and others released Mumps V1, an implementation of Mumps similar to DSM-11. Mumps V1 has since been ported to Linux, Mac OS X and Windows. Initially only for the x86 CPU, Mumps V1 has now been ported to the Raspberry Pi. The newest implementation of Mumps, released in April 2002, is an MSM derivative called M21 from the Real Software Company of Rugby, UK. There are also several open-source implementations of Mumps, including some research projects. The most notable of these is Mumps 2, by Dr. Kevin O'Can and Students Project. Dr. O'Can has also ported the interpreter to Mac OS X. One of the original creators of the Mumps language, Neil Papalido, early founded a company called Meditech. They extended and built on the Mumps language, naming the new language MIIS. Unlike InterSystems, Meditech no longer sells middleware, so MIIS and Magic are now only used internally at Meditech. On January 6, 2005, and later again on June 25, 2010, ISO reaffirmed its Mumps-related standards, ISO IEC 11756 1999, Language Standard, ISO IEC 15851 1999, Open Mumps Interconnect and ISO IEC 15852 1999, Mumps Windowing Application Programmers Interface. Current users of Mumps applications. The U.S. Department of Veterans Affairs was one of the earliest major adopters of the Mumps language. Their development work was an influence on many medical users worldwide. In 1995, the Veterans Affairs Patient Admission Discharge System, Decentralized Hospital Computer Program was the recipient of the Computer World Smithsonian Award for Best Use of Information Technology in Medicine. In July 2006, the Department of Veterans Affairs/Veterans Health Administration was the recipient of the Innovations in American Government Award presented by the Ash Institute of the John F. Kennedy School of Government at Harvard University for its extension of DHCP into the Veterans Health Information Systems and Technology architecture. Nearly the entire VA hospital system in the United States, the Indian Health Service, and major parts of the Department of Defense CHCS hospital system use Mumps databases for clinical data tracking. Large companies currently using Mumps include MaryPath, CareCentric, Allscripts, Epic, Coventry Healthcare, EMIS, Partners Healthcare, Meditech, GE Healthcare, and Sunquest Information Systems. Many reference laboratories, such as DASA, Quest Diagnostics, and DynaCare, use Mumps software written by or based on Antrim Corporation code. Antrim was purchased by MIS Healthcare in 2001. Mumps is widely used in financial applications. Mumps gained an early following in the financial sector, and Mumps applications are in use at many banks and credit unions. It is used by Ameritrade, the largest online trading service in the U.S. with over 12 billion transactions per day, as well as by the Bank of England and Barclays Bank, among others. Since 2005, the use of Mumps has been either in the form of GTM or InterSystems Catcher copyright. The latter is being aggressively marketed by InterSystems and has had success in penetrating new markets, such as telecommunications, in addition to existing markets. The European Space Agency announced on May 13, 2010 that it will use the InterSystems Catcher copyright database to support the Gaia mission. This mission aims to map the Milky Way with unprecedented precision. Overview: Mumps is a language intended for and designed to build database applications. Secondary language features were included to help programmers make applications using minimal computing resources. The original implementations were interpreted, though modern implementations may be fully or partially compiled. Individual programs run in memory partitions. Early Mumps memory partitions were limited to 2048 bytes, so aggressive abbreviation greatly aided multi-programming on severely resource-limited hardware, because more than one Mumps job could fit into the very small memories extant in hardware at the time. The ability to provide multi-user systems was another language design. The multi-programming and the acronym of language name point to this. Even the earliest machines running Mumps supported multiple jobs running at the same time. With the change from mini-computers to microcomputers a few years later, even a single-user PC with a single 8-bit CPU and 16K or 64K of memory could support multiple users, who could connect to it from video display terminals. Since memory was tight originally, the language designed for Mumps valued very terse code. Thus, every Mumps command or function name could be abbreviated from 1 to 3 letters in length, for example quit as Q, $p equals $piece function, R equals read command, $tr equals $translate function. Spaces and end-of-line markers are significant in Mumps because line scope promoted the same terse language design. Thus, a single line of program code could express, with few characters, an idea for which other programming languages could require 5 to 10 times as many characters. Abbreviation was a common feature of languages designed in this period. An unfortunate side effect of this, coupled with the early need to write minimalist code, was that Mumps programmers routinely did not comment code and used extensive abbreviations. This meant that even an expert Mumps programmer could not just skim through a page of code to see its function but would have to analyze it line by line. Database interaction is transparently built into the language. The Mumps language provides a hierarchical database made up of persistent sparse arrays, which is implicitly opened for every Mumps application. All variable names prefixed with the character use permanent storage, will maintain their values after the application exits, and will be visible to other running applications. Variables using this shared and permanent storage are called globals in Mumps, because the scoping of these variables is globally available to all jobs on the system. The more recent and more common use of the name global variables in other languages is a more limited scoping of names, coming from the fact that unscoped variables are globally available to any programs running in the same process, but not shared among multiple processes. The Mumps storage mode gives the Mumps database the characteristics of a document-oriented database. All variable names which are not prefixed with character are temporary and private. Like global variables, they also have a hierarchical storage model, but are only locally available to a single job, thus they are called locals. Both globals and locals can have child nodes. Subscripts are not limited to numerals, so any ASCII character or group of characters can be a subscript identifier. While this is not uncommon for modern languages such as Perl or JavaScript, it was a highly unusual feature in the late 1970s. This capability was not universally implemented in Mumps systems before the 1984 ANSI standard, as only canonically numeric subscripts were required by the standard to be allowed. Thus, the variable named car can have subscripts door, steering wheel, and engine, each of which can contain a value and have subscripts of their own. The variable car door could have a nested variable subscript of color, for example. Thus, you could say, to modify a nested child node of car. In Mumps terms, color is the second subscript of the variable car. Hierarchical variables are similar to objects with properties in many object-oriented languages. Additionally, the Mumps language design requires that all subscripts of variables are automatically kept in sorted order. Numeric subscripts are stored from lowest to highest. All non-numeric subscripts are stored in alphabetical order following the numbers. In Mumps terminology, this is canonical order. By using only non-negative integer subscripts, the Mumps programmer can emulate the array's data type from other languages. Although Mumps does not natively offer a full set of DBMS features such as mandatory schemas, several DBMS systems have been built on top of it that provide application developers with flat file, relational and network database features. Additionally, there are built-in operators which treat a delimited string as an array. Early Mumps programmers would often store a structure of related information as a delimited string, parsing it after it was read in. This saved disk access time and offered considerable speed advantages on some hardware. Mumps has no data types. Numbers can be treated as strings of digits, or strings can be treated as numbers by numeric operators. Coercion can have some odd side effects, however. For example, when a string is coerced, the parser turns as much of the string into a number as it can, then discards the rest. Thus the statement if 20100 printer performs printer if n is greater than 100. This construct provides a conditional whose scope is less than a full line. Abbreviation: you can abbreviate nearly all commands and native functions to 1, 2, or 3 characters. Reserved words: none. Since Mumps interprets source code by context, there is no need for reserved words. You may use the names of language commands as variables. There has been no contest such as the International Obfuscated C Code Contest for Mumps, despite the potential of examples such as the following: perfectly legal, Mumps code. Mumps can be made more obfuscated by using the contracted operator syntax, as shown in this terse example derived from the example above. Arrays are created dynamically, stored as B-trees, are sparse, can use any number of subscripts, and subscripts can be strings or numeric. Arrays are always automatically stored in sorted order, so there is never any occasion to sort, pack, reorder, or otherwise reorganize the database. Built-in functions such as $data, $order, $next, deprecated, and $query functions provide efficient examination and traversal of the fundamental array structure, on disk or in memory. Local arrays, variable names not beginning with character stored in memory by process, are private to the creating process, expire when the creating process terminates. The available storage depends on implementation. For those implementations using partitions, it is limited to the partition size. For other implementations, it may be several megabytes. Global arrays, ABC, def. These are stored on disk, are available to all processes, and are persistent when the creating process terminates. Very large globals are practical and efficient in most implementations. This is Mumps' main database mechanism. It is used instead of calling on the operating system to create, write, and read files. Indirection, in many contexts, at VBL can be used, and effectively substitutes the contents of VBL into another Mumps statement. Set XYZ equals ABC. Set at XYZ equals 123 sets the variable ABC to 123. Set subrow equals report do at subrow performs the subroutine named report. This substitution allows for lazy evaluation and late binding as well as effectively the operational equivalent of pointers in other languages. Piece function, this breaks variables into segmented pieces guided by a user-specified separator string. Those who know awk will find this familiar. $piece, string var, 3, means the third caret separated piece of string var. The piece function can also appear as an assignment target. $piece, world.std.com. 2, yields std. After. Set $p, x, at, 1, equals office causes x to become office at world.std.com. Order function, this function treats its input as a structure, and finds the next index that exists which has the same structure except for the last subscript. It returns the sorted value that is ordered after the one given as input. $order, stuff, yields 6, $order, stuff, 6 yields 10, $order, stuff, 8 yields 10, $order, stuff, 10 yields 15, $order, stuff, 15 yields. Here, the argument less for repeats until stopped by a terminating quit. This line prints a table of I and stuff, I, where I is successively 6, 10, and 15. For iterating the database, the order function returns the next key to use. Multi-user multiprocessor, Mumps supports multiple simultaneous users and processes even when the underlying operating system does not. Additionally, there is the ability to specify an environment for a variable, such as by specifying a machine name in a variable equals foo, which can allow you to access data on remote machines. For a thorough listing of the rest of the Mumps commands, operators, functions and special variables, see these online resources, Mumps by Example, or the book of the same name by Ed de Mol. Much of the language syntax is detailed there, with examples of usage. The annotated Mumps language standard, showing the evolution of the language and differences between versions of the ANSI standard. Criticism equals, the Daily WTF, a site devoted to sharing programming horror stories, includes a sharply critical article describing one programmer's experience with Mumps' syntax and features. Mumps versus M naming debate. While of little interest to those outside the Mumps M community, this topic has been contentious there. All of the following positions can be, and have been, supported by knowledgeable people at various times. The language's name became M in 1993 when the M Technology Association adopted it. The name became M on December 8, 1995 with the approval of ANSI X 11.1-1995, both M and Mumps are officially accepted names. M is only an alternative name, or nickname for the language, and Mumps is still the official name. Some of the contention arose in response to strong M advocacy on the part of one commercial interest, InterSystems, whose chief executive disliked the name Mumps and felt that it represented a serious marketing obstacle. Thus, favoring M to some extent became identified as alignment with InterSystems. The dispute also reflected rivalry between organizations as to who determines the official name of the language. Some writers have attempted to diffuse the issue by referring to the language as M, UMPS, square brackets being the customary notation for optional syntax elements. A leading authority, and the author of an open-source Mumps implementation, Professor Kevin O'Kane, uses only Mumps. The most recent standard still mentions both M and Mumps as officially accepted names. Intellectual property and trademark registration status. Massachusetts General Hospital registered Mumps as a trademark with the USPTO on November 28, 1971, renewed on November 16, 1992, and expired on August 30, 2003. See also, PSL an extension to Mumps, Catch a copyright object script an object-oriented extension to Mumps from a prominent Mumps vendor, ESI Objects an open-source object-oriented extension to Mumps, GTM an implementation of M. References. Further reading, Walters, Richard. ABCs of Mumps. 1989, Butterworth Heinemann, ISBN 1-55558-017-3. Walters, Richard M. Programming, A Comprehensive Guide. Digital Press. ISBN 1-55558-167-6. Lukowicz, John. The Complete Mumps, An Introduction and Reference Manual for the Mumps Programming Language. ISBN 0-13-162125-4, Kersen, Wolfgang, et al. Object-Oriented Application Development Using the Catch a Copyright Post-Relational Database ISBN 3-540-00960-4, Martinez de Carvajal Hedgerich, Ernesto. El Lenguage Mumps. Completa obra en castellano sobre el lenguaje Mumps. ISBN 84-477-0125-5. Distribuido exclusivamente por su author, O'Kane, K.C. A Language for Implementing Information Retrieval Software, Online Review, Vol 16, No. 3, pages 127-137. O'Kane, K.C. and Mayer Colligan, E.E., A Case Study of a Mumps Intranet Patient Record, Journal of the Healthcare Information and Management Systems Society, Vol 11, No. 3, pages 81-95. O'Kane, K.C. and Mayer Colligan, E.E., A Web-Based Mumps Virtual Machine, Proceedings of the American Medical Informatics Association 1997, O'Kane, K.C., The Mumps Programming Language, CreateSpace, ISBN 1-4382-4338-3, 120 pages. External links, M Technology and Mumps Language FAQ General Source. Also specific source for the Potras quote re the origin of the 1840 epoch. Mumps Language Interpreter, Kevin O'Kane University Northern Iowa, MDC, Mumps Development Committee, The Annotated MUMPS Standards, GTM, Mumps Systems, SourceForge Index, Globals, A Primer for Relational Programmers, M-Links at hardhats.org, M21, an ANSIM, UMPS. Implementation, ESI Objects an object-oriented extension of Mumps, InterSystems Catch a Copyright, MDB an open-source Mumps-based API-compatible alternative to SimpleDB, Minim Database Server, a Mumps implementation, development and operation of a Mumps laboratory information system, a decade's experience at Johns Hopkins Hospital, Idea Systems Technology Solutions based on Catch a Copyright and GTM, Mumps documentation, topics, and resources.